Share screen. Yeah, we can start the session. Sorry for the inconvenience. There was an some internet connection issue. Yeah, it's fine. Yeah, welcome to all for this next second session of interactive session of this NPTEL social network course. Yeah. Let me introduce myself again because many students have joined newly here. So I'm Swapnil Mane, a PMRF research scholar at IIT Jodhpur. I'm working in a social network analysis and application group, which is affiliated to CSE and IIT Jodhpur. My primary research area is in social network analysis and natural language processing. Yeah, let's move to the our question answer discussion. The primary goal of this interactive session is to discuss the questions, your doubts, and I will discuss the questions which has been published the previous year questions, assignment questions. So this is an second week assignment questions. We will discuss about it, and also you will clear your doubts, or you will understand some concepts as well. Okay. Yeah. So let's move to the first question. Yeah, which of the following statement is true? Right. Statement one, which is an email network, is directed network. Is it correct or not? That we need to find out. So another is another statement, which is an co-authorship network is an undirected network or directed network. So what do you think, guys? Is this statement, both the statements are correct, or no, neither one statement and second statement is correct? What do you think? Yes. Anyone? I hope you understand the concepts has told in this week. So this is a simple things. The how what is an means which application, which network is an directed network or indirect undirected network that we can form. So email network. Do you guys know that how the email network created? Anyone? Yes. And what about the authorship network? Is it directed or indirected? What do you think? Co-authorship is an means two or more people are collaborating with each other for doing some projects. Okay, so for that they are connected. If they are collaborating, then there is an age. Okay, so if they are not collaborating or not doing any projects together, then there is a no age in between them. Okay, so, what do you think in that case? If there is a direction, is it necessity, or what do you think? It's not required. So, yeah, the email network. Let's discuss it. How the email network. Let's see. This is and the options are there. So, email network is that. We So there is an let's take a one node which is an one person represented here. Another person is there. One person A is posting or mailing to another person, right? So this direction. So the person A and person B, right? Person A is mailing to a person B. So there is a direction will be there, right? So likewise, the network is created. For the person A gets mail from C node, likewise the network is created. This is how may the email network may create it, right? And what about the co-authorship network? So in the co-authorship network, so the node A, so the node A is there and node B is there. If they are collaborating for any project, or they are doing any project together, then there is an age in between them. So as you can see, they are collaborating. So there is no as such directions are required in this case, right? In this applications. So this is an undirected graph. Right? There is no directions is required here. Right? Suppose they are following any work from any person. So suppose the A person is following means he's extending the work of any person. So in that case, so there might be age can be introduced. So A is extending work of the B. Likewise means A is following the B's work. Likewise, okay. In that case, the direction should it requires. But in the co-authorship network, in collaboration network, there is no means the direction is required. That means this network is an undirected network. So here the both the options are correct, statement 1 and statement 2 as well. Okay, so the option 3 is correct here. Okay, let's move to the second question. So what is the clustering coefficient of open node that has 4 neighbors and 3 connections in between those neighbors? So first of all, what is a clustering coefficient? What do you think? Yes. What is a clustering coefficient? Anyone? You can also write comment in the chat box as well. That is fine. Yeah, number of links in between the nodes. Nodes means which nodes? So if we consider, yeah, neighboring nodes, that can be right. That is in correct option maybe. Because in a graph, you can consider there is an n nodes are there. And if you consider only the links in between the nodes, there is no as such meaning of considering only the edges for the clustering coefficient calculation. Okay. The clustering coefficient, which says that, which measures the degree to which a nodes in a graph tends to cluster together, means how much capacity of the node to cluster, to make a cluster. Clusters means that is one community actually, means they are connected together strongly. Okay, likewise. So let's see how the clustering coefficient we are calculating for a node. Okay. So there is an one for equation that is already discussed in the lecture series. Okay. So suppose we have to calculate a clustering coefficient, that is in C, clustering coefficient of a node. Let's take a node. Okay. Yeah. So for the clustering coefficient, calculating the clustering coefficient for the A node, so let's take a node here, and there has a friends of the A nodes. Okay, these are the friends of the A nodes. Okay, that is a neighboring nodes of the A nodes. Let's take as an C, B, D. Likewise. Okay. So, so clustering coefficient, and let's take have connections in between. They have connections. Okay. The clustering coefficient says that how we are calculating it. So there is an number of edges in between the neighboring nodes of A. Whose neighboring nodes? A's node neighboring, right? So neighboring nodes. So the what are, means currently what are the how many edges are there in between the neighboring nodes divided by possible number of edges. How many possible number of edges in between the neighboring nodes are there, right? Yeah, here you can see that the total number of So generally, what do you means four you are giving one digit actually. So that digit is for which, referring to which concepts? I am not getting it. 4 6. What is that? So here, the in between number of edges in between the neighboring nodes, you can see here the neighboring nodes are C, B, D, E. Right. So in between the C, B, D, E, how many edges are there? Huh? How many edges are there here? So here only one edge is there, right? In between the B, C, D, E, right? So this is the numbering. That is a number of edges in between the neighboring in the current graph. Okay, and divided by possible edges in between the neighboring nodes of A. How we are calculating the possible edges? We are getting that number of edges in between the neighboring nodes of A. We got as an one edge in between, right? That we found. But how we will get possible edges in between the number of neighboring nodes of A? How we are getting? So in last session we have already discussed that how we can calculating the how many possible edges in between the graph, right, based on the number of nodes, right? So how we are calculating it? How the 6 is coming Janini? So 4 edges is not, yeah, the 4 nodes are there, right? So 4 choose 2. See means how many possible edges we are finding from a graph. We are taking a total number of nodes from the graph, and then the edge, for drawing the edge we require 2 nodes, right? So the possible edges are the number of nodes C2, right? Which is here the number of nodes is that how many number of nodes are there? 4 C2, right? Four numbers, number of neighboring node, four node, right? Neighboring nodes are there. From this neighboring node, how many possibles we have? In the graph there are total 5 nodes are there. You can see here this is an also a node. So we are not taking the fifth node as well. Only we are taking the considering the neighboring nodes of A. Okay. So here considering the 4 C2, how we are calculating the calculation, that is a 4 into 3 divided by 2, right? 4 to so 6 we are getting, that is possible edges as in 6. So let's take 1 divided by 6. So the answer is 1 divided by 6 uh, for this A node. The clustering coefficient of A is an 1 divided by 6. Are you guys understood? Is how we are calculating it, right? Then simple formula we are utilizing here, that is a number of edges in between the uh, current number of edges in between the neighboring nodes of A divided by possible number of edges in between the neighboring nodes of A. So based on that, suppose in between these neighboring nodes there are higher means near to 6 edges are there, then there is a clustering coefficient score is very high. Right, very high means it goes to up to 1 means, right. Higher is that means higher they are densely connected, right? Their neighbors are densely connected. So suppose let's take one example how it look like means that you are saying that notes are there, right? So this is a, and we are drawing on edges. So yeah, so suppose let's take in between the nodes there are edges are there, from this node to this node, from this node to this node, right? From this node to this node. Yeah, I think all possible edges. You can see how densely this network it's connected. Compare this network and this network. It shows, so clustering coefficient you can calculate by yourself after this session. So the clustering coefficient we are getting here, right, which is about something point, I don't know, right, 1 divided by 6, but it's near to 0. But after calculating the clustering coefficient for this network, for this A, considering this graph, you will get a higher than this clustering coefficient. That means this network is densely connected, has a tendency to make a cluster, new cluster, dense cluster together. Right? Okay, yeah, let's move to that question. What it is saying that what is the clustering coefficient of a node that has four neighbors, right, and three connections in between those neighbors? Yeah, let's take a minute, go through this equation and calculate it by yourself. That we have the similarly how we have calculated now, right? For a node, we have calculated the clustering coefficient, right? Taking as a number of nodes in the numerator, denominator is a possible number of edges in between the neighboring nodes, right? So take a minute and calculate it. Let me know what is the answer of this. Yes, anyone has got the answer? Clustering coefficient of a node that has four neighbors and three connections in between those neighbors. Yeah, Pratik, point for you. And how we got it? What is the numerator value and what is the denominator value in this case? Right. Three. Yeah, three are the connections in between those neighbors, and the possible connections in between the neighbors as an six. You are saying that, and how six is coming out? Right? How we are calculating the possible edges, which is and 4C2 in this case. 4C2 means 4 into 3 divided by 2. Right? So we are here. Yeah, Joshiva, you are saying something. So here the correct answer is that the point 0.5. I will also calculate here. Many students may not understand that how the clustering coefficient is getting here. So I will also draw a network by considering this. So you can see here there is a four neighbors and the three connections in between those neighbors. Right. So yeah. So considering this, let's draw a network for the simplicity, for the sake of simplicity. Okay. Uh, Joshiva, you are saying something? You raised your hand.
Good evening, sir. Sorry
Yeah.
for
Yeah, no problem. Yeah. Okay. So here, let's take a node. That node name is an A node. Okay. And as question says that the node has four neighbors, right? Let's take one. Let's forget about the direction and directed. Let's take as an only directed as an four neighbors are there. Right? These are the neighbors which has name and see like the same network we have considered previously, right? So we need to calculate the clustering coefficient for this A node. Okay. Yeah. and it is saying that in between the neighboring nodes of A, how many neighboring nodes are there? There are four neighbors are there, but in between the neighboring nodes, there are three connections are in between there, right? So the connection we can draw any edges. We can randomly draw edge, any edge in between those neighboring nodes. Okay, here let's take a black node as in one, two, three, right? These three connections I have taken. So here the neighboring nodes are one, two, three, four, right? And the edge you can see here. This is an edge in between them. The one edge, two no edge, and three edge. So our clustering coefficient formula says that there is we require a total number of connections in between the neighboring is already given in the question, which is an 3. Okay, divided by possible connections between the neighboring nodes. So the possible connection in between the neighboring node, we require the total number of nodes in the neighboring nodes. So here total number of neighboring nodes are 4, right? So how we are calculating the total number of possible edges, which is and 4C2. Okay. So the 4C2 into 3 divided by 2, right? Which is and 6. Okay. So here's no 6 no. Wait, 6. Yeah. Something is wrong. In, yeah, right. So we are getting as in point 0.5. Okay, so means this option is 2. I hope you guys understood the question. I understood the answer actually. Okay. Let's move to the another question, which is we need to calculate the density of a given graph. Density of graph. So first, let's understand what is the density of the graph. How we are calculating the density of the graph. Before that, can anyone explain what is a degree distribution? What is a degree distribution? So whatever I am asking, that is, these are the basic questions, has already covered these concepts in the week slides, weeks videos actually. Yes. What is a degree distribution? What is a degree? Degree of a node. What do you mean by degree? Anyone? Okay, degree means how many edges that node has. Okay. For sake of simplicity, let's consider only undirected graph. In that case, let's take a how many edges in between the node, in between the each node. No, Abhishek, means in between the nodes. It's not means, say here the node is there, right? Like let's take this previous example. So in this case, so let's take this example. Okay, so for this in this graph, you may see graph notation value. Okay. So here the degree of C means degree of C means here how many edges the C has. The C has in edges 2, means degree of C node is in 2. The B degree is 3. E degree is in 3. 3 edges that A has. Okay. You can see this out edges has going na. That's why the F node has in 2 edges.
Okay, okay, sir. Got it.
Right, understood. Yeah. So degree distribution is that how many occurrences of the degrees are in there in the graph. Means suppose we got a degrees as in 3 for node. This is a 1 node, 2 node, 3 means the label of the node. Okay, 4 node. So let's take as in 4 node as in 5, 3, 2. Okay. So you can see here. So the node is there. So degree distribution is that how many occurrences of the degrees is in the graph is there. Okay, so in the degree distribution we are getting as in 3, the 3 occurrences in 2. Okay, likewise the 5 has 1, 2 as in 1, likewise. Okay, so this is a degree distribution. We can see how we can, how the degree is distributed in the graph. For the analysis we can see that we have to calculate the density. So the density is same that how we are calculate the clustering coefficients near about that. The density is how densely connected the network is, whole network how densely connected is that. The complete graph we know that the all possible edges are in the network are in the graph is there, right? Means there is any node can reach to any node in the graph. So that is in the complete graph case, right? But the density calculation, it says that how densely and how many possible edges are inserted in the graph, which is more likely to the complete graph. Okay, so let's take that is a simple formula, number of edges in the graph divided by possible number of edges in the graph. So in this graph, let's see. You can see here the number of edges in the graph. How many number of edges you can see here? There is an 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So there are 10 edges are already exist in the graph. Okay. And the possible edges, how we are calculating the possible edges? By considering number of nodes. So here you can see the 4, 5, 6, 7. 7 nodes are there. 7 into 6 divided by 2. Right, 21. So we got as an 10 divided by 21 for this graph. Yeah, there is an option 1. It's correct. So how the 9 divided by 21? Yeah, the answer is an 10 divided by 2. Because you can see here that is a total number of edges here. 10. Okay. The correct answer is an 10 divided by 20. Is there any doubts in this question? Okay, let's move to the another question. Find the clustering coefficient of a node B in the given graph. Yeah, please take a minute and please solve this question, as already we have solved 2 times clustering coefficient problem. Uh, take this problem as maybe you will solve easily in a minute actually. Take a minute and please solve it. Let me know that what is the answer of this question. Okay. Yes, what is the answer? Clustering coefficient of node B. See, the node B has an 3 neighboring nodes. Okay. In 3 neighboring nodes, there is an connections are also there. There is 2 connections are there in between the neighboring nodes. Right. The neighboring node C, D, A. In between the CDA, there is an 2 connections are there. So calculate it, please let me know what is the answer about it.
3, sir.
3 is not answer. How you are getting the 3?
I think 2 by 3.
Yeah, 2 by 3 is it correct answer? Yeah, but 3, how you are getting 3 value? Yeah, Josiba. So yeah, let's calculate it again. Maybe 2 divided by C. How you are getting it? 2. Yeah, that is correct. Yeah, let's solve it. Maybe some students are not getting it. Yeah, let's take directly answer the how many, that formula says that how many connections in between the neighboring nodes. The neighboring nodes are these. The connections are one, two, right? The two connections are there. Divided by how many possible connections are there. For possible connections, we require uh, 1, 2, 3. Three nodes are there, so we are taking 3C2, 3 into 2 divided by 2, right? That is, this is the correct answer. Yeah. I hope you got this question here. Yeah, this already discussed. Yeah, the another question: which statement accurately reflects the characteristics of the node edges, node degrees according to the power law distribution? Yes. So, what do you think? Which option is correct? Anyone? Three small number of integers. Why do you think this is correct answer? First of all, let's see what is an power law distribution. What power law distribution says. We already discussed the node degree distribution, right? How the degree distribution we can plot it or get calculated. Yes. What do you think that the three option is correct? What power law distribution says? Yes, anyone? Yeah, let's. Hmm. Right. And vice versa. Large number of nodes have lesser connections. So in videos, you might seen that in the lecture, in the implementation session, in the implementation video, they have in the instructor has a plotted a plot of the degrees, right? The plot look like where can the plot look like this is an our plot. In x-axis there is an degree, right? Degree, and the count here, the y side, y-axis is an count of that degree, count of that degree, and we are getting a plot like this way, okay? Like this way. Means you can see here the less degree nodes who have those nodes has means there are large number of nodes are there who has a less number of degrees. You can see here the less number, these are large numbers of the degrees. And uh, large degree nodes, their counts means number of nodes has a very less here, okay? The number of nodes for the higher degree it's less, and number of nodes for the lesser degree those counts is very high, okay? This power law distribution, this plot shows an power law distribution. So any real time network it shows an power law distribution properties, okay? This is, I mean, you can see, take a real time example that in our Instagram social network platform, there you can see that there is a no all users has the same number of followers, right? there is an only few number of users who has higher number of followers, right? Those are the influencer, we can say that, or those are popular politicians, or many maybe a popular actor out there, right? Those users has an higher number of connections are there. Yeah. And that is an unpopular users, those means there are number of unpopular users are there, right? So unpopular users has an less number of pages. So in this case, consider this, imagine this scenario. In this scenario looks like many users has a less number of, many numbers of users has less number of ages, less number of their followers, and very few number of users who has higher number of followers, right? Yeah, Abhishek, how it relates with the link prediction task? What do you think that means? What do you mean by mean that? Yeah, here the option is three is correct. That is, in a small number of individuals, that is, any users or nodes have substantial higher number of connections are there compared to the majority. The first option, what the first option is that every individual in a social network has equal number. This is not possible in real time connections, right? All users had doesn't have the same number of follower counts. Okay, exhibit a second is an exhibit a uniform distribution of connection among all users. This is also not possible. Like each node has an identical degree prompting equality in the connectivity. That's same, it says that. Okay, but it's not correct. In real time it's not possible. All connections has, all nodes has, all users has same number of followers. It's not possible. Yeah, let's move to the another question, which is, and what is the diameter of the following graph? Yeah, so first, what is an diameter of the graph? What do you think that, what is the diameter? Yes, anyone? Yeah, yes, Janil. Distance between the fastest, farthest nodes. Yeah, it's the longest path. Longest path means longest, shortest path in between the nodes, but that is a very maximum as compared to the other shortest path. Yeah, it's correct, Janini. Yes, and maximum shortest path means, uh, suppose we have a 5 nodes, and let's take this graph, and we have calculated how many for each node to each node. Suppose I need to travels from one node to every node. How many paths I'm getting, means how many shortest paths I'm getting. From that, which one is the maximum? We need to check for all the nodes, and from that, we need to take which one is the maximum length. Maximum length shortest path is there. So here, what is the answer? 4, Pratik. How the four is getting? Where is the maximum shortest path is getting? I think you are not getting it, means. So shortest paths, we need to find the how many possible shortest paths, and from this shortest path, which one is the maximum length. Here you can see that, yeah, generally the 2 is the correct answer. So from you can see that 1 to, if you want to traverse from any node to any node, that maximum shortest maximum could be the 2. Greater than 2, it's not possible. You can, in 2 hopes you can reach to any node. Okay, 1 to 2, like 3. Suppose 1 to 3, I need to, well, then in this way, in this way, like 4 to 2, then this way to this way. This is how we are um, reaching to the node. This is the maximum. So that maximum shortest path means diameter of the graph. Understood. Okay, let's move to the another question. Which of the following format was created as part of the Giphy project? So what? Let's understand what is an GIFI project firstly. What is a GIFI? Yes, there is a special one video has created for that a GIFI. The hands-on explanation has already given in the video series. What do you mean by GIFI? What for? What reason it is used other than the network X? We have already network X. Yeah, for the better network visualization. Yeah, that's true. GIFI project. Yeah. So, so what do you think? Which format is for the GIFI project is created part of the GIFI project? Is Gmail or GX5, XF, GraphML, Pachek? So Gmail is an right. Suddenly more said that. Let me join by share screen. Yeah, I hope my screen is visible, right? Yeah. So where I'm saying that is in graph modeling language, GML, right? Uh, Hello, I'm audible. Anyone, please respond. Yes. Okay. Yeah, got it. Uh, right. Let's see the one by one what exactly the JML. These are the different formats we can store the graph or network in our hard disk. Okay, physical memory. So there are multiple formats we can store the graph, which is an in CSV, at HTML, GXF, GraphML, PAGEC, right? There are multiple formats we can store it, and there is an different attributes or different properties of each file, uh, each format. Okay, so that is an GML, which is an the text file format, which is used to describe the graph. Okay, and another is an graph exchange XML format. The XML language, you may familiar with the XML language, how we can write our XML code, right? Likewise, we are described our graph in the XML format, right? This is an GXL. And then after that graph ml in this graph ml, which is an another xml based file format. It is not exactly used and it's not created by the GIFI project, but it's widely used in various graph analysis tools. Okay. Another is an PAJAC. This file format is used by PAJAC software for large network graph analysis. Okay, it's not related also JFI project, but this second one, that is an graph exchange XML format. This is mostly means it is developed by the GIFI project to store the network data. Okay, which is an designed to easily read by any humans or any machines. Okay. Yeah, the answer is an GEA. But you can see the GIFI project can read any format file. Means you can pass any CSV file as well, any JML or a GraphML file as well. Okay, there is no issue in that case. Yeah, let's move to the another question, which is an given a graph G with V vertex, the number of vertices and N nodes, and a number of edges E, a modulo E, number of edges are there. In each of the following cases, we can guarantee that G is connected. So, as in the video lecture, Dr. Iyengar already proved a theorem, which is that what is the probability or what is the threshold uh, for number of edges is required to uh, for to the graph will be connected. In the result graph will be connected. So that is an n log n, right? That is a probability threshold. It's not a guaranteed. Right? It's not guaranteed that is an graph it is an connected. It is an possibility. It's a probability, minimum probability. It should be it's get connected. Let's analyze other options as well. There is an suppose n edges are there, then it is connected, or n minus one edges are there, it is connected. Right? Yes. So understand. Let's analyze that option three. What do you think about that? What is the formula for this? Means which for this equation we are using for which purpose? Yes. Right. Total number, which shows that complete in complete graph we are calculating number of edges. It's not a possible. We are not here, we are calculating as a probability, but here that it gives a distinct number which is an absolute number, which gives an means total number of edges. This is a total number is means in complete graph, suppose 5 nodes are there. In that 5 node, how many possible edges are there? Those edges, they are saying that those edges are we are inserting in the graph. Then what the graph look like? It is connected or disconnected? Pratik, considering this number of total number of possible connections in the graph, what do you think that this graph is connected or disconnected? But surely what we can say that, yeah. So in fourth option, that is a possibility, that is a probability threshold it is giving for that how much minimum edges can be inserted in the graph. In that result, we get a graph which is unconnected. Right? This is one way that. But in third option, that is, and we are getting a total number of edges, possible edges. In that, surely guaranteed that the graph will be connected. Right? Yeah, in this case, the option three is correct. Yeah. I hope you guys understood. If not, please let me know. Yes, Mogolapa. Yes. Do you have any doubts? Hello.
सर एक बार आप रिपीट करेंगे क्या म्हणजे समझ
Ah,
में
yeah,
नहीं
sure,
आया.
sure. Sure, no problem. See, here what we are doing here. So let's take a this answer. So we have three nodes. Let's take a randomly node. Okay. So we have one, two, three, four. Let's take 5 nodes. More complex. So these are the now 5 nodes are there, and this is one a graph. Okay, but there is a no edge in this graph. Now this graph is a disconnected, and which has 5 components. Components. This is act one component. This act this act as one component. This act as one component. This is a disconnected graph. Okay. Right. So yeah. Okay. Then we have inserted a edge in between this node. Okay. That is, and one two nodes are connected, and there is an here the 4 components are there now. Then we have added the. So how many edges we need to insert in this graph so that the graph will be connected, right? As we have seen that in previous or in video series, week videos as well, and also our previous discussion, we have calculated many times in degree density calculation, cluster coefficient. We have denominator, we have calculated that total number of possible edges, total number of possible edges in between the nodes for a given nodes number. So we have here, we have so how many possible edges in this graph? So here the n, that is total number of nodes are 5 are there. So how many possible edges? That is a 5C2, which is n into n minus 1 divided by 2. Right. Also, this formula shows that how many edges are how many edges are in the complete graph, are in the complete graph. What is means by complete graph? Complete graph means every node to every node there is a direct connection. Okay, so every node to every node there is a direct connections are there. Okay, so the direct connection, for the direct every node to every node direct connection possibility, we require this formula. This formula will gives the how many edges will be required to make a graph, a complete graph. Okay, so that's why we suppose we are getting for these 5 nodes, let's add 5 here and 4 divided by 2 and 2, right? This, right? So 10 no edges we will add here. There is no greater than 10 edges will be possible here. Okay, if you are added 10 edges here in this graph, then the graph is total completely connected. There is no possibility to add extra edge in between them. In this case, right, you can see here, so we have added 1 2 3 4 5, fifth edge we have added 5 6 7 8 9 and 10, right? There is no extra possibility here. Greater than 10 we can't add here. You can see here, in this case the graph is connected. It's not possibility to graph is disconnected, right? It is a guaranteed that graph is connected. Yeah, I hope you understood this concept. Yeah, which of the following, let's move to the next question. Which of the following statement is true for a GML format network? Many students are still joining. It is not. Which of the following statement is true for GML format and uh, format of networks? So here, what is an GML format networks? Right? Maybe you remember that how the GML format look likes. So there are two statements as given. The first statement says that labels and attributes can be added in that format file, and also we can add the weights, can be weights of the age or nodes we can add there. So in CSV file, you can see that there are only the bits we can add, but suppose we want to add the attributes of the nodes and ages, there is not possibility in the CSV file, that age list you have seen, right? So in JML, what do you think that in JML it is possible or not? Should we, is it able to add labels, attributes in the node ages are possible or not? What do you think that? Before that, please let me know what is an GML format look like. Anyone? Yeah, I think you guys seen in the video. Maybe you are not recalling it, but just have a that is an one. I will give a rough idea how it look like a GML graph, GML format for file, which is an yeah, graph node, Pratik, yes, it's correct. That means we have added a graph in a list, right? In this list, there is a node. We have added in that node. There is a list is there. Then we can add their label of this node, which is an one. Then attribute we can add here, right? Also, we can add the weight of this node here, 0.5 like this. This way we can add the node, another node, like with here. After the node, then we can add age also. Here you can write the age, right? Then you can add the label of age, means label of the age, right? That is, and means you can label of the age means you might be confused here. The label of node we can understand that, but what is the label of? There is an heterogeneous graph may be there. Heterogeneous graph means what? There are multiple types of ages are inserted, or are there in the graph. Actually, the multiple types of ages means the one age is represented as a friendship relationship, another age is represented as a following relationship. There is another nodes also, heterogeneous node. Heterogeneous graph means, maybe this concept will cover in the next slides, next videos also in the course. But I will give a rough idea about what is a heterogeneous network. As of now you understood a simple network which is an, there is an, suppose email network we are considering. There is an people one, people person one, person two, there person three. There is an age between the between the persons, which is that he has person one has mail to person two. There is a directed age in between them. This is a simple network, right? The heterogeneous network is that the multiple types of nodes are possible in the network. Multiple types of nodes, multiple types of ages are possible. Multiple types of nodes means what? Right. Let's take a Twitter network. In the Twitter network, there is a heterogeneous network can be possible, like that. There is a node that is represented as a user. Another node is an user two, user one, user two. There is age between in between them. This means they are following each other. If they are following each other, then there is an age. There is also another node which is a tweet node. Okay, so user one has posted a one tweet one. So there is an age between user one and that post. That is undirected age. Likewise, maybe you might get a confused. I will draw. Is the here we can draw. So here we can node user one, user two. This is a following relationship. Right? Let's take a directed graph. U1 is following to U2, right? Like that. Following, right? There is another node which is an T1 in the same graph, in the same network. Okay, so there is an age in between them, which is also directed age. So this T1, which is an type, it is an post. U1 has posted this T1. Likewise, right? There is also another possible thing. There is another T1, T2, and this is age between the T1 to T2. This age type might be retweet of T1 to T2. Right? T1 has retweeted T2 post, maybe likewise retweet. Right? This is a heterogeneous network. You can see here multiple types of nodes are there in the graph. Multiple types of edges are also possible in the graph. Right? Likewise. But these are the specified types. It's not dynamically added any type of the nodes. There is another problem, maybe there is a dynamic graph. This is a static graph. Let's consider as a static graph. I'm using many words here. There might be confused in this terminology, but don't get confused. Only understand the what is the network look like as of now, and how networks we are storing the graph in the format, various format. Okay, yeah. Yeah, maybe, yeah. In this graph, Gmail already said the see the how we can store the data in this format. That is, and various attributes, labels of the node, which we can uh, assign to the node here, and we represent it in the in this file. So the two options are correct. So in both options are correct here. Okay. So yeah, last question is that in mentioned, which is in mentioned in video lectures, in synonym network, why might be there a path between words like love and hatred? I will explain a question a bit detail here. That is, an synonym network means what? We have a bunch of words, English words are there, maybe greater than 1 lakh or 1,000. Yeah, right. The word one, word two, word three, word four, word five, likewise. Okay, greater than 1,000, 1 lakh maybe. And we have considered this network, we consider this node, each word as a one node in our network. So here one W1 is a node, W2 is another node, W3 is an. There is an age between word 1 and word 2 if they are synonym to each other. Right? Synonym to each other, then there is an undirected age in between them. Like, so this is how the synonym network is created or designed. Right? So here they are saying that there is a love word node is there, and, and there is a multiple synonyms possible for this low word is the network, and after the multiple synonyms there is another word node is an hate node is there. So they are saying that if this is a synonym network and they are connected to each other, how they are synonym to each other. Right? Actually, in this graph, in this network, there is a degradation of the synonym is happening. Actually, means you are going to farthest, then there is an shift to the semantic meaning. Actually, means you are you are acquiring new meaning of the word, or you are evolving to the opposite concepts of that particular nodes. Opposite concept means opposite word, opposite of this means antonym of this word. Okay. Yeah, option 3 is correct here. That is, and words can undergo semantic shifts. Semantically shifts their context. Okay, and acquire a new meaning. Say, and evolve or represent to opposite concepts. Okay. It's not like that this is connected to this, that is already mentioned in the lecture. Actually, that is, and this is connected to this is connected to this, means these nodes are similar. It's not like that. If here means there is a loss or there is a degradation of the synonyms in between. It's not the A is equal to B, B is equal to C, and then A is equal to C. It's not possible here in this network. Okay. Yeah, I hope you understood the questions and some concepts here. Maybe these concepts and this question maybe it will be helpful for your assignment for the assignment two. Okay. Yeah, that's it for this week. Is there any doubts or any if you want to discuss anything? Yes. Yes, first week live session recording is available. All the live session recording is available to everyone. What we are doing actually, we are recording this lecture. We are posting this or uploading this lecture on YouTube channel. Okay. So I already uploaded the last week live session in the on the YouTube. You can access. What you can do, you can go to the NPTEL your page, and at the you will see the week 1, week 2, week 3 tabs, right? And at the end of these tabs, there is a live session tab is there. Right? In that you will find the recordings of the live session. Okay, in the NPTEL page itself. Yeah, already posted on the announcement, which is, and it will soon posted on the assignment too. Let's wait. Yeah, in 2 3 days maybe it will post it. Okay. Don't worry about that. It is an easy. It's similar to what I conducted here. That is similar to similar questions are there. Okay. Most of the cases. Yeah. What I can do, I will show. One sec. There is an problem solving sessions tab is there already in the NPTEL portal. Don't worry, I will share it here. Stop the recording and share it my desktop screen. Yeah, got it. Yeah. Yes. Anything else? Otherwise, we can conclude this call. Okay.
सर
Yes.
आप सोशल नेटवर्क एनालिसिस दोनों पढ़ाते हो क्या?
No, it's not about social network analysis, only social networks. How the social network is designed and how we can store it, how we can manipulate it, how we can use for the any applications design. Okay. There is another course, social network analysis, which is taught by Dr. Tanmay from the IIT Delhi, which is another course of the NPTEL. It's two different courses actually. Okay. Yes, anything else? Otherwise, we can end this call. Okay. I hope there is no question. If you have any between any questions, let me know. You can write a mail to me. My mail address already mentioned in the PPT. Maybe you have noted down. Okay. Yeah, that's it. Thank you. Bye bye.